Good morning, students. Today we are going to one more method of the Newton forward interpolation formula in terms of the derivatives. Let me know that what is the meaning of numerical differentiation. Numerical differentiation is the process of computing or finding the value of the derivative dy by dx for some particular value of x from the given table or data when the actual from the function is not known is called numerical differentiation. Now let us prove the theory part of the derivatives using Newton's forward interpolation formula. We know that previous classes we proved also Newton-Gregory forward interpolation formula, that is like this: y equals to y naught plus p delta y naught plus p minus 1 2 factorial delta square y naught plus p minus 1 p minus 2 by 3 factorial delta cube y naught, called equation number 1. Now where p is equals to x minus x naught by h, called equation number 2. Differentiate equation 1 with respect to p, we get in this form: dy by dt left hand side, dy by dp equals to y naught is constant, its differentiation goes to 0. Here p with respect to p is 1, delta y naught, plus here p into p square minus p is there. So p square differentiation is 2p, p differentiation is 1. How will get it? First to multiply this p into p minus 1, we will get p square minus p. P square differentiation is 2p and p differentiation was denominator as it is, delta square as it is. Here first multiply all the three, p minus 1, p minus 2, will get in terms of the third degree equation. That equation we can differentiate with respect to p, will get 3p square minus 6p plus 2 divided by 3 factorial delta cube y naught, called equation number 3. A differentiate equation 2 with respect to x, equation 2 is here, with respect to x, will get dp by dx is equals to x with respect to x is 1, x naught is constant, there 1 over h. Now dy by dx is written as dy by dp into dp by dx. Now we write dp by dx already here, dp by dx is 1 over h, dy by dp here, equation 3, we get delta y naught plus 2p minus 1 by 2 factorial delta square y naught plus 3p square minus 6p plus 2 by 3 factorial delta cube y naught plus and so on, called equation number 5. The equation 5 represents, or equation 5 gives the values of dy by dx at any x, any value of x. We can substitute x is equal to 1, 2, 3, 4 and etc., which is not tabulated. The equation 5 becomes simple for tabulated values of x. In particular, when x is equal to x naught, p is equal to 0. Put p is equal to 0 in equation 5 here in the right hand side. Then we'll get dy by dx at x is equal to x naught 1 over h. Put x is equal to x naught and p is equal to h. So 1 over h delta y naught, then p 0 here, p 0 will get minus 1 by 2 delta square y naught, p 0 here, p 0, then p 0 means here this is 0, this is 0, will get 3 factorial is 6. Here 2 is left, 2 by 6 is 1 over 3. Here actually these two values goes to 0, 2 as it is, 3 factorial returns 6. Then 2 by 6 is 1 by 3, delta cube y naught minus 1 by 4 delta 4 y naught plus and so on. Also differentiate equation 5 with respect to x, this equation 5 will get, here left hand side is dy by dx, differentiate value get it d square y by dx square we have. So 1 over h as it is. Now differentiate, delta y naught is a constant, then differentiate with respect to x is 0. Then next it is 2p minus 1, then d square by, again Equation 5 with respect to we have d square by dx is d by dp, dy by dp, dp by dx. Then d square y by dx square is equals to 1 over h 2 by 2 factorial d square y delta square y naught plus 6p minus 6 by 3 factorial delta cube y naught plus 12p square minus 6p 36p plus 22 4 fact delta to the power into 1 over h. Here dp by dx value this 1 over h. Then d square over dx square differentiate equation 6 will get d square by dx is 1 over h as it is. This is goes to 0. This differentiation again differentiation will get, and substitute p, putting p is equal to 0 here. Then d square by dx square x is equal to x naught will get 1 over this h into h, 1 over h square, delta 2 get cancelled, delta square y naught, then 6 p is 0 here, then 3 factorial into 6 get cancelled, then we'll get delta cube y naught plus here 4 factorial is there, p substituting means all these two values are zeros. These two terms goes to 0, 22 by 24, that is 4 factorial is 4 3s are 12, 12 2s are 24, 24 2s are 20, 24 2s are 48, then 22 by 12, then delta to the power of 4 y naught. So these are the two important equations. When this is the first derivative, this is second derivative. Let us move on to the try to do some examples. Find dy by dx and d square by dx square at x is equal to 0 from the following table. The table is like this. X values are 0, 1, 2, 3, 4, 5 and y values are 4, 8, 15, 7, 6, 2. Then from the table we know that very well here. You find the first forward difference table. X values are 0, 1, 2, 3, 4, 5. Y values are 4, 8, 15, 7, 6, 2. And find the first difference. First difference 8 minus 4, 4. 15 minus 8, 7. 7 minus 15, minus 8. 6 minus 7, minus 1. 2 minus 6, minus 4. Then second differences. 7 minus 4, 3. Minus 8, minus 7, minus 15. Minus 8, minus half, minus plus 8. Plus 8 minus 1 plus 7, minus 4 plus 1, minus 3. Then these are the second order differences. Now next we find the third order, fourth order as it is like this only. And here we consider this is delta y naught value, delta square y naught value, delta cube y naught value, delta to the power of 4 y naught value, delta to the power of 5 y naught value. We'll get like these values. So we know that already formula. We have a first derivative dy by dx x is equal to x naught, that is equal to 1 over h delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta to the power of y naught plus 1 by 5 delta to the power of, called equation number 1. D square by dx square is x is equal to x naught is, this is also formula 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta to the power of 4 y naught minus 5 by 6 delta to the power of 5 y naught. Now here h is equal to 1 and x naught is 0 here. From the table we know that variable x naught is equal to 0 and h is 1. X is then delta from the table these values know that delta y naught value is 4, delta square y naught is 3, delta cube y naught minus 18, delta to 40, delta to the power of 5 y naught is minus 72. Now all the values substitute in equation 1 and 2. Now I am substituting these values in equation 1 and put x is equal to 0 there. Dy by dx is equal to x is equal to x 0. H is also 1, that is 1 over h. H value is 1. Delta y naught value is 4 minus 1 by 2 as it is. Delta square y naught value is 3 plus 1 by 3 as it is. Delta cube y naught value is minus 18. Minus 1 by 4 as it is, delta to the power of y naught is 40 plus 1 by 5, delta to the power of 5 y naught is minus 72. Now very simple mathematics is there. Let's simplify this. We'll get minus 27 by 9. Like this also These are all the values, h values, x naught, and all the differences values. Substitute in equation 2, we'll get d square y by dx square at x is equal to 0, 1 by, here h is 1 by 1 square, it is 1 square, 3. Delta square value is 3 here, 3 minus as it is, delta cube value is minus 18, minus of minus 18, plus 11 by 12, delta to the power of 4 y naught is 40, minus 5 by 6, delta to the power of 5 by delta to the power of 5 y naught is minus 72. Again here simplification, we do simple mathematics is there, as some addition and subtraction, we will get 117.67. Now next move on to the one more example. Find dy by dx and d square by dx square at x equals to 51 from the following data. This is the data, and we consider dy by dx. Suppose here y is there, dy by dx. Suppose f of x is there, f dash of x. Y is equal to f of x, y dash is equal to f dash of x. Y double dash is d square by dx square, that is equal to fx double dash. So from the table we clearly know that h is 10 here, and p we can find x minus x naught by h, this formula. Our x is here 51, 51 minus 50 by 10, 51 minus 1, 51 minus 51 by 10, then this 0.1. At x is equal to 51, p value is 0.1. From this table we find the forward difference table, then x values are 50, 60, 70, 80, 90. Then p values are, we have p values are, p is equal to x minus x naught by 10. Then y values are 0, 1, 2, 3, 4, 5. Then y value is 19 minus 96, 36 by 65, 58.81, 77.21, 94.61. Then first differences, 36 plus 6, 36.65 minus 1996 will get 16.69. 58 point, this minus this, that means 58.81 minus 36.65 will get 22.16. Like this we can find the first order. 77.21 minus 58.81 will get 18.40. 94.61 minus 77.21 will get 17.40. Now second order, 22.16 will get 5.47 minus 3.76 minus 1.0. Then third order, this minus 9, minus 3.76 minus 5.47 get minus 9.23, minus 1.0 minus of minus plus 3.76, 2.6. This minus this will 11.99. Then this is the delta square y naught value, delta square y naught, delta cube y naught, delta to the power of 4 y naught. By using the Newton's forward interpolation formula for the derivatives, I'll be writing the first one, dy by dx at x is equal to 51. Then dy by dx p is equal to 0.1. The 1 over h delta y naught plus 2p minus 1 by 2 factorial delta square y naught plus 3p square minus 6p plus 23 by 3 factorial delta plus 2 delta cube y naught minus and so on 4p cube minus 18p square plus 22p minus 6 by 4 factorial delta to the power of 4. This is the formula. Now here h is 10 from the values of x, 60 minus 50, h is 10, 1 by 10. Then as I told, from the difference table, forward difference table, we'll get delta square y naught value, delta yu, delta cube. Substitute values here. Delta y naught is here 16.69, 2 write as it is, 2, p is here 0.1, 0.1 into 2, 0.2 minus 1. I will once again explain. This p value is 0.1, 0.1, as you know that here p value is 0.1, this 0.1 into 2, 0.2 minus 1 by 2. Then delta square y naught value is 5.47 here. This is the delta for y, 5.47. Substitute 3 as it is, p value is as I told 0.1, that 0.1 whole square minus 6 of 0.1 plus 2. Delta cube y naught value is minus 9.23 plus 4. Then p cube is 0 point whole cube minus 18 0 point whole square plus 22 0.1 minus 6 24. 4 factorial is 24. Then 11.99. This is the delta to the power of 4 y naught value. Again here simple mathematics is there. We simplify this. We will get 1.0316. So find the second derivative. D square by dx square at p is equal to 0.1. This is the formula. 1 by h square delta square y naught plus p minus 1 delta cube y naught plus 6p square minus 18p plus 11 by 12 delta to the power of 4 y naught. 1 by 100, h is 10. 10 square is 100. Delta square y naught value will get from the forward difference table, that is FDT 5.47 plus P 0.1 minus 1. Delta cube y naught also get from the forward difference table minus 9.23 plus 6.0.1 square minus 18 of 0.1 plus 11 divided by 12. And delta to the power of 4 y naught value is 11.99. 1 divided by 1 divided by 100 and 5.47 as it is. Simplification of these two 8.307 and remaining 9.2523. Simple mathematics is 0.2303. These are the some examples. So one more example, find dy by dx and d square by dx square at x is equal to 1 from the following data. X values are 1, 2, 3, 4, 5 and f of x value is 0, 6, 24, 60, 120. Then instead of here f of x, y, f of x is there. Y dash nothing but f dash of x. Here from the table we know that very well. 2 minus 1, 1, h is the 1, x naught is 0. From this table we can find the forward difference table, as you know that already previous two examples. And after constructing the forward difference table, now you write the Newton forward interpolation formula for derivatives. Dy by dx at x is equal to x naught. This is the formula 1 by h delta y naught and so on. Dy by dx at x is equal to 1, sub h is equal to 1. Delta y naught is 6, this is minus 1 by 2 delta square root 12. 1 by 3 delta cube is 6 minus 1 by 4 delta to the power of 4 y naught is L0. Then 6, then 2 1 ja 2 6 ja, then this is 6, 3 1 ja 3 2 ja, 6 minus 6 0, this 2 0, this is 0 2. Then second one, and d square over dx square at x is equal to x naught is equal to 1 by h square delta square y naught minus delta cube y naught plus 11 by 12 delta to the power of 4 y naught. This is from formula, and substitute here values. D square over dx is x is equal to 1, that is h is 1, 1 by 1 square, delta square y naught value is 12 minus 6 delta cube value, then 11 by 12 delta to the power of 4 y naught is you from the table get. Then this is 0, 12 minus 6 6. Now this is one more formula. This is one more problem. Try to solve. This is find example 4. Find dy by dx and d square by dx square at x is equal to 2.2 from the following table. Here consider different one here. In the previous cases we have a h is it is a 1 2 like this. Here h is 1.6 minus 1.4, it is 1.2 here h. So here these are the x values, y naught values. Try to solve this one. Okay, students, we can meet in the next class. So next move on to the one more method, that is the backward interpolation formula. Derivatives using the backward interpolation formula. We know that in the previous classes how to write the backward interpolation formula, that is y is equal to yn plus p nebula yn plus p into p plus 1 by 2 factorial nebula square y1 plus p into p plus 1 p plus 2 by 3 factorial nebula cube y1 plus and so on. P is equal to x minus xn by h. Now here in the backward and forward, what is the difference? How we can find the p value means, in the forward interpolation formula, p P is equal to x minus x naught. Here x minus xn divided by h. Xn means the last value of the given value of the x. Dp by dx is 1 over x. Differentiate this with respect to x. We got 1 over h. Then dy by dx can be written as dy by dp into dp by dx. Dp by dx you write 1 over h dy by dp. From differentiate this with respect to p one time. Then this goes to 0. You'll get p differentiates with this. You will get here nebula yn. From this p into p plus 1 write p square plus p differentiate with respect to 2p plus 1 divided by 2 factor nebula square yn. Here first these three factors multiplied p into p plus 1 p plus 2 will get p square plus p square plus p multiplied by p plus 2 will get 3p cube plus 6p plus 2 divided by 3 factorial nebula cube by 1. Call this is equation number 1. At x is equal to x1, p is 0. Hence putting p is equal to 0. We get here wherever p is there, we substitute 0. That means dy by dx at x is equal to x naught, 1 over h, nebula yn, 1 by 2, p 0 here. 1 by 2 factorial is 2, nebula square y1. Then 1 by p value means these two terms 0. 1 by, here 2 is there. By 3 factorial 2 by 6 1 by 3 nebula cube y1 plus 1 by 4 nebula square yn plus 1 by 5. These are the values. You will get next values. Then dy again differentiate equation 1 with respect to x. Then we will get d square y by dx square is d by dp of dy by dx dp by dx. dp by dx is 1 over h here. d by dp dy by dx. What is dy by dx? dy by dx is here from the equation. This equation again differentiate with respect to x. Then we'll get 1 by h nebula square yn plus 6p differentiation of this is 0. We come this one. Differentiation of p with respect to p1. Then this is 0. Then 2 by 2 1 it is. We'll get only nebula square y1. Here differentiate with respect to p. That is 3p square. It is 3p square actually. 3p square. It is a 6p plus 6. It is not 3p cube. It is a 3p square. Then 6p plus 6 by 3 factor nebula cube yn. And 6p square plus 18p plus 11 by 12 nebula to the power of 4. Next term. You get this. And this dp by dx is 1 over h. And putting p is equal to 0 here is also will get d square by dx square at x is equal to x naught 1 over h. Then wherever then p is there we substitute here 0 will get this equation 5. We can derive the above formula in another method. 1 minus nebula is equal to e to the power of minus d. Then next move on to the one example. The population of the certain town is given below. Find the rate of growth of the population in 1971-1961. Year 1931, 1941, 1951, 1961, 1971. Population in thousands. 40.62, 60.80, 79.95, 103.56, 132.65. Here h is 10. 1941 minus 1931 h is 10. Then using this we can find the forward difference table like this. As you know this is the forward difference table. But we are using this is xn value. Xn is 1971. Yn is 132.65. Then this is nebula square yn, nebula square y1, nebula cube y1, nebula to the power of 4 y1. Look here, we found the difference forward difference table, but you take the tables below values. The end of the table below values, those are the nebula values. Then to obtain f dash 197.1, we use the backward formula. This is the formula. Then after substituting p is equal to 0, then 1 by 10 nebula yn is this one, 29.0. Then 1 by 2 as it is, nebula square 1 is 5.48. 1 by 3 as it is, nebula cube is 1.02. 1.4 nebula to the power of 4y minus 4.4. Now simple mathematics is there here, some addition and subtraction. With that, after simplification we get 3.1052.5. Then to get 1961, p is equal to x minus x1 by h. 1961 minus 197 by 10, that is minus 1 here. Look here, when finding f dash of 1961, p value is minus 1. So dy by dx at x is equal to 1961, dy by dx p is minus 1. The one more has, this is the formula. So 1 by 10, then nebula y value is 29.05. Then here p is equal to minus 1. Minus 2 plus 1 minus 1, that is minus 1 by 2. Here we substituting p is equal to, we are substituting p is equal to 0 at x is equal to x naught. When x is equal to 1961, we are substituting p is equal to minus 1. So we'll get minus 1 by 2, 5.48. Here is also substituting p is equal to minus 1. Minus 1 whole square is plus. This is plus 3. Minus 6 plus 1. Then 3 plus 1, 4. Okay. That is 3 plus 1, 4, minus 6, minus 2. Then we get minus 1 over 6, 1.0, minus 1.6, 1.02. Then is next one, minus 1 by 12, minus 4.47. Again simplify, you will get the value 2.6552.5. Now again we are given an example from the backward interpolation formula for the higher derivative, single derivative, second derivative. Now try to solve this one.